Hello friends, myself Ravi and today I am here to give some information or whatever on architecture of JVM. So in last video we have learned about JVM, JRE and JDK. So in today's video we will discuss in deeply on architecture of JVM. So because there is a main part of the main part of the JDK, that is JVM. So we will talk about JVM. So what is the work of JVM or why we need JVM? Because to execute our bytecode or to run our bytecode we need a JVM. So Java provide interface to execute the program into two stages. That is, first we compile our program into class file, that is bytecode, and after that it will interpret or run through JVM and we got our output. So we know that Java is platform independent or Java code is platform independent, but the JVM which executes the Java program, that is not that is platform dependent. I said platform dependent because for every version or every software or every OS, every hardware, it requires different version of JVM to execute their program. So JVM is platform dependent, and the second part, that is it is a virtual, because when we install JDK we can see JRE and the JDK files, but we can't we never see JVM. So it is a virtual and it doesn't require memory. So I will tell you the structure of JVM. JVM mainly consists into three parts, that is first class loader, second memory area, and third is execution area. The first class loader. Class loader further divided into three parts, that is first loading, second verifying, third initialization. Okay. So first loading. Loading consists or the main part of three. It load the class files. It load from three types, that is first bootstrap, that is .js files. It means it store or it loads the files through bootstrap. Second, which is you can say that .ext or extensions .exe. It load the extensions which are required to run the programs, and the third is APK files which are required in the execution of the program or in the class. The second part, which is we can say loading of loading, that is verification. Verification consists of further three parts, which are first pre-processing. It means it process the file, because when we got the bytecode or the code program file, it will check whether the code is executable for running or not. So the after that we have after pre-processing we have verification, verify the code whether it is executable or not. The third part is it resolute or provide memory or provide its memory, which is its we can say it initialize the variable to its default value. And the third part, that is initialization. In initialization, it provides the real memory or the real values to the variables. The next part, that is memory area. Memory area mainly consists of five parts, that is class area or method area, and the second is heap, the third stack, fourth PC register, and the fifth is native area. The memory area stores or memory area or class area store the class files or class means the files which are statics or class area are stored in the method area or class area. The second is heap store the references areas or virtual references area or objects which we create. It store the object or we can say the array elements in the heap. The third part is stack. Stack store the local variables, methods, etc. required to execute the program. For every method execution, it store or it create the new area, stack area to execute the program. The fourth part, that is PC register. PC register mainly store the address of the command. So when we give the command, or when is the command given to the program to run the program, that the next command is stored in the PC register. And the last part of memory method is memory area, that is native methods. Or native method store the methods which are dependent on OS. So in our program there are some methods which depend on OS, or which are directly dependent on our operating system, that are stored in native area. So after that, the last main part, that is execution engine. Execution engine mainly consists of three main parts, that are interpreter, JIT, that is Java runtime, just in time. Third is garbage collector. So interpreter interpret the codes line by line and execute it, and process it line by line. So the second part, that is JIT. JIT reduce the work, or reduce the we can say jumbling work that can be done by interpreter. JIT means it interpret or compile the code which are same type of code and which are repeated in the program at the same time. So JIT required less required, or JIT doesn't get affected by that. Interpreter reduce the work of interpreter is reduced by JIT. And the last part, that is garbage collector. Garbage collector is it free of the memory which are not used or not. So suppose if there is an object is declared at the top, and but it doesn't use in the whole class, then it will remove it while processing or while compiling it. So it free up the memory spaces. So with this, I like to finish the topic, that is architecture of JVM, and I like to say thank you.